Alright, final page. Alright, so we got number 49. Looking back on our other one, this said that it wanted us to rationalize the denominator. Okay, that was our instructions for 48 as well. So what we have to do on this one, since we got an expression on the bottom that has a radical in it, we have to do what we call the conjugate, right? And this dates back to our, or has this same line of thinking that came from our difference of squares. So we're going to do our 9 plus the square root of 5 to get rid of this, okay? And remember, when we did this with the difference of squares, we did 9 times 9, and because we don't need this, this would be a positive 9 square root of 5 and a negative square root of, or negative 9 square root of 5. Those would cancel away. So we really have to do the middle, the front together and then our back together, right? So let's do that. Also, whatever we're multiplying times our bottom, we're going to do times our top. Okay. So when we do that, 9 times 9 is 81. Okay. Remember, when we multiply these together, we're going to get a negative, right? But this is 5 times 5, which is 25. The square root of 25 is just 5. Remember, it just comes out like that. And so on this one, we're going to multiply our 3 times our 9, which gives us our 27. And then this one can't get multiplied, so this is just going to be a 3 square root of 5. Okay. Now we still need to simplify this right here, so we get 27 plus 3 square root of 5. We get something that multiplies by 3, which probably isn't going to happen since we're taking this something that can get divided by 3 and minusing 5 from it. So 81 minus 5 is 76. Okay? And we can't simplify that any further, so that's going to be our answer for 49. If you could, you would try to divide all 3 of those numbers by it, and that happens. Alright, this one says to solve. We got z minus 1 equals the square root of 43 minus z. Anytime we have a square root right like this in our problem, we're going to want to go back and make sure this works. So anytime you have that when you're solving, just make sure that you do it, because sometimes it doesn't. Well, so what we're going to have to do to get rid of this, though, is we're going to have to square both sides. Right? We're going to have to square this, and we're going to have to square this. Now the beauty of squaring this one is these just cancel away. It's like this square cancels this square root. Okay. Then on this one, we're going to have to FOIL this one out. Okay, and I'm going to do it the fast way again. Hope that you're starting to catch on that way, but this is going to be z squared. Okay, multiply this times each other, we get a negative z, and then double it, so we get a negative 2z. And then we have negative 1 times negative 1 is plus 1. And this equals this. This just comes out 43 minus z, which was kind of our point. Okay. Now let's bring everything on this side. Right. We're going to add a z here, add a z here, and then subtract our 43 here. Subtract our 43. So what we get is z squared minus z, right? Minus 42. Because 1 minus 43 is a negative 42. And now this equals 0. Okay. And basically what we can do is we can split these out into linear factors. I'm still doing it the easy way. You're welcome to do it with the quadratic equation. But something that multiplies to be negative 42, we can go down our list and eventually we're going to end up at a 6 and a negative 7 is what we're looking for, right? That multiplies to be negative 42 and also adds to be a negative 1. So this is z plus 6 and z minus 7, right? And if we're solving this, so as to use a nexus, z plus 6 equals 0, and z minus 7 equals 0. So if we solve this, we get z equals negative 6, because we're going to add negative 6 to both sides, right? And also z would equal 7, because we're adding 7 to both sides. Okay? So that's our possible solution so far. So we want to plug these back in and see if our answers work. So let's go ahead and plug this one in. So our first one we get is z minus a negative 6 equals the square root of 43 minus negative 6. Okay. Well, when we have a double negative, let's go ahead and make those both pluses, right? And so, I'm really goofy. Really goofy. This would be negative 6. And this is minus 1. So, we're probably catching that and screaming at the video, right? Well, negative 6 minus 1 is a negative 7. And this equals the square root of 49, right? And already we're starting to see, hey, negative 7 doesn't equal 7. Okay, so that disqualifies this answer. We can't answer this as negative 6, right? Let's see if our 7 works. So we got 7 minus 1 equals the square root of 43, and this is minus 7. Right? Well, 7 minus 1 is 6, right? And then the square root of, and then 43 minus 7 is 36, so the square root of 36 is 6. And that does equal that, right? So this one does work. So this is going to be our answer we're going to use. Make sure that you disqualify some of those answers. Okay? Otherwise, you're going to lose half the credit, or they might even count it all wrong on your final exam. 51.
Okay, we have the square root of negative 4. Now, we need to take out this negative out of the square root. Now, we know that we can do that because I equals the square root of negative 1, right? This is an imaginary number to have a square root be a negative. So, what we can do first is we can actually take out that I, and then we have the square root of 4. Okay, and now we know what this is. Square root of 4, we can put that in the calculator. It's going to tell us that it's 2. Okay, so that 2 comes out, and we have an I. So this is our answer. Alright, now we have the square root of negative 300. Okay, so once again, we do like we did in the previous one. We're going to take out an I, right? So we got I out in front, and we got the square root of 300. Okay, so first thing we want to do is break this thing down. Okay, we can break it into 3 and 100. Okay, so from here, I know that 10 times 10. We can actually make the pair right here. I'm going to break it all the way down to prime factors, though, that just because you might be in the habit of doing that. Okay. So we're looking for a square root, right? This number is an imaginary 2 right here. This is telling us that we need 2 matching numbers for that number to come out of our square root, right? And so then we got a pair of 5s right here. Okay. But this 3, remember they split, these made these two things, and this split into those two things. So this is the only other prime number that we have here. And it didn't have a match to go with it, so it has to stay under the radical. So this answer to this one should be, well, we got a pair of 2s that come out, a pair of 5s, so that's 10. We still have our imaginary, so 10i, and then that 3 is still under the square root, so this is our answer. Square root of 36 here, and then we get I, and then 64. Now square root of 36 is 6, so this is going to be 6i times, and square root of 64 is 8, and so this gives us 8i. Okay, so from here we're going to multiply this. This becomes 48. 6 times 8 is 48, and then I times I is I squared. Okay, now coming back to that line of thinking, with our I equaling a -1, this would be like the square root of -1 times the square root of -1, right? Now, one thing we can't do on here is we can't multiply these two together and create a positive, because these are imaginary numbers. All this ends up happening is this actually becomes the matching number that's under the square root. So if we do the square root of -1 times the square root of -1, this actually equals -1. Okay, so that's actually what we did. We did an I times an I, which is what I squared is. This equals a -1. So 48 times a -1, that gives us a -48. Now we have 5 plus 7i minus 9 plus 10i plus 5 plus 9i. Okay, we're not going to be doing any multiplication in this one, which is almost what you'd be tempted to do, to distribute all that stuff, but there's just subtraction and addition between these things, so there's no multiplication going on. The only thing that we really have to do in our first step is distribute this negative throughout our parentheses right there. Okay, so there's nothing more to solve in this one. We can actually break or take down our parentheses. We don't need them anymore. We got 5 plus 7i. This distributes, gives us a -9. This distributes and gives us a minus 10i. Okay, then we can just drop these down as well. So this is plus 5 plus 9i. Now, we have things that are the same, right? So we have our 5, we got our -9 here, and we have our 5, which is all like terms. Okay, so first things first, this will add up and give us 10, right? And then this subtracts and only gives us a 1. So 10 minus 9 is 1. Then we're going to combine these. We can combine these first. These are both positive. We can say this is 16i, and then it's minus 10i, which only gives us 6i left over. So this is our final answer. This is 1 plus 6i. This one we're doing 2 minus 8i, and then we're multiplying that times 3 plus 3i. So what we have to do, we have to FOIL this one. Remember, FOIL means first It means the outside, it means the inside, and then the last ones. So we're going to do the first. So 2 times 3 is 6. And then we're going to go 2 times 3i, which is 6i. If we do a negative 8i times 3, that gives us a negative 24i. And then if we do a negative 8 times a 3, that's a negative 24. But it's I times I, which gives us I squared. Now we know from doing the last one, this I squared is actually going to turn into a negative 1. So when that happens, we have a negative 1, which is what this is, and that negative 1 gets multiplied times this negative 24, which gives us a positive 24. Now we have some like terms, right? We have this group and this group, and then we got this group and this group. So let's add these first. 6 plus 24, that is 30, right? And if we do 6 minus 24, that gives us a negative, which is makes us put minus here. This is 30 minus 18i. Okay, so it gives us this 6 plus 2i over 9 minus 3i, and we're supposed to rationalize the denominator. Now we're going to use the principles that we learned in the difference of squares to achieve this and make sure that we don't have a square root in our denominator, which is what that I is. So we're going to look at this like it's an expression, and we're going to multiply this expression times the thing that would make it different in the difference of squares. We got minus here, so we're going to multiply it by the plus version of that expression. Now, whatever we do the bottom, we're going to have to do the top. So we're going to have to multiply this times this 9 plus 3i. Now, let's go ahead and do the top first. That's a little bit more tricky, so we're going to have to FOIL this one. So 6 times 9 is 54. And then 6 times 3i is 18i. Okay. And then 2i times 9 is another 18i. And then 2i times 3i. Well, once again, we got another I squared, which is going to make this be a negative 1 is what we end up with. But 2 times 3 is 6. So 6 times negative 1 gives us a negative 6 on top here. Okay. Now, when we're doing difference of squares, remember these two, the outside and the inside, kind of counterbalance each other. So all we have to do is the first, which is 9 times 9, which is 81. Ignore the outside and the inside, and we just do the last. So this is negative 3 times 3, which is negative 9, and then I times I is I squared, which is a negative 1 again. Now negative times a negative is a positive, so this is plus 9 here. Okay, we can combine like terms. Here, this is 54 minus 6, which is going to be 48. And we're doing 18i plus 18i, that's going to be a 36i. And this is over 90, right? 81 plus 9 is. So there may be different ways that your instructor likes you to write this. We can certainly reduce this, and I'm gonna break this apart to where we have this over this and this over this. That way we can reduce this. So we have 48 over 90 plus 36 over 90i. This is kind of the standard way to express this. We can divide these both by 6, and so this gives us an 8 over 15. we can actually divide both these by 18, right? And so 36 divided by 18 is 2, and 90 divided by 18 is 5. So this should be your answer. 8 over 15 plus 2i. All right. We have I to the 19th power. Okay, and we need to see what that actually equals, because we can simplify this down a little bit. Now, one thing we're going to discover about I, and this might be a little bit of a review for you, I actually equals the square root of -1, which we're just going to say is going to equal I. Okay. Now let's start looking at where these powers go as we just increase them. So if we go to I to the 2nd power, because this was out of the 1st, this means that we have an I times an I, which means that we have the square root of -1 times the square root of -1, which we talked about this earlier. This actually equals a -1. Now, I to the 3rd would be like us having I squared times I. Now, we've already determined I squared actually equals a -1. So this equals a -1, and we're timesing it times an I. So -1 times I just gives us a -I. Then we get I to the 4th. And so this is like I squared times I squared. Remember, that's I squared is like a -1 times another -1. So -1 times a -1, that's a +1. You'll notice if we did this, I to the 5th, I to the 4th would equal to 1, and so we'd end up saying that I to the 5th actually equals I. And you have this repeat with this these same 4 things keep going on and on. So what we really need to do is figure out how many times this cycles through with doing 19. So the easiest way to do that is to take whatever your power is and divide it by 4. Okay, now we know that 4 goes into 19 4 times, right? And 4 times 4 is 16. Now here's the big key, is we want to do this subtraction. 19 minus 16 is 3. This remainder actually tells us where this is going to be, because it follows I to the 3rd. Okay. If we have 0 remainder, it follows the suit of this one, because it goes in an even number of times, so your answer should equal 1. Okay. So what we're saying is I to the 19th is actually equal to -I. So this is your answer, -I.
We got 2n squared plus 19 equals 43. Alright, so it says use the square root property. Okay, so what we're going to do, we're going to minus our 19 here, minus our 19 here, and so we get 2n squared on this side equals, and then we're just doing 43 minus 19, 43 minus 19, is 24. So then we're going to divide everything by 2. And get n squared equals 12. Now what we're going to do is get the square root of both those sides. What that does, well, write the square root. This is going to give us the plus or minus. Anytime we're taking a square root of something, we're going to end up with a positive and negative version of this. Okay? So this comes out as n, and we get plus or minus, or this comes out into 3 and 4, and this is 2 and 2, right? These 2's can come out, and we got a square root of 3 left behind. Okay, and that should be our answer. We can also write this we can also write this as 2 square root of 3 and negative 2 square root of 3. Okay? All right. Now we're going to do 52, still using that square root property. Okay, and we got 7x plus 6 squared equals 49. So what we do to get rid of this is we take the square root of both sides. You don't have to do all this writing. I'm doing it just so you can visually see this. A lot of people skip this step and just come straight down and write 7x plus 6 equals plus or minus the square root of 49. So you can do that. I don't feel like you can't, but that's what we're going to end up doing. Anyways, I just want you to see that it's that, and then we're taking the square root, and then it just comes out like that. Okay? All right. So we can simplify this, right? This is plus or minus 7, right? Square root of 49 is 7. And so then we get 7x plus 6. Okay. And then we're going to minus 6 from both sides. Minus 6 from both sides. And so we get 7x is equal to negative 6 plus or minus 7. Don't just take one away from, or take that and say it's plus or minus 1, because that's not the case. We've got to do the plus and minus version of these. Okay? And our last step is to divide this by 7. Okay? Now, we end up with x equals negative 6 plus or minus 7 over 7, right? This also means, we got two different things going on. So we got negative 6 plus 7 divided by 7. And we also have negative 6 minus 7 divided by 7. Okay, so if we simplify these down, we're going to get 1/7, right? That's negative 6 plus 7 is 1, and that's over 7. And over here, we're going to get negative 6 and negative 7 make a negative 13, right? And that's over 7 as well. So this is our solution set. All right, 54. Oh, 53. Trying to skip y'all. So n squared plus 18n equals negative 70. Okay. And they've got this one already set up for us. Okay. So remember, our first step, okay, is we're going to take our middle term, that's 18, and we're going to divide it by 2. Okay? I'm getting all out of whack on here. 18 divided by 2 is 9, right? And then our second step is we're going to take that number and square it, right? And that gives us 81. Okay, and after we're done with that, then we add that to both sides. So we're going to have n squared plus 18n plus 81. Okay. And then we're going to do negative 70 plus 81. Right? So once we do this, this is going to simplify into n, and then we're going to use this thing in our thing. So it's going to be plus 9. So what do we get on that first step? That's what you're going to put here, and it's going to be squared. If we refoiled this thing out, we'd end up with this expression there. Okay. And then we do negative 70 plus 81. That's going to be 11. Okay. Now from here we're going to take the square root of this. Okay. What that does is make that turn back into n plus 9. Okay. Remember, we get the plus or minus version of this. That's the plus or minus square root of 11. And we can't really simplify that down any further. It's still plus or minus the square root of 11. And so then we're going to minus 9 minus 9. So this is going to be n equals negative 9 plus or minus square root 11. If he wants you to split that out, this is going to be negative 9 plus or minus square root of 11, comma, negative 9 minus, plus the square root of 11 minus the square root of 11. All right. Final proof. All right, 54. All right, we got w squared plus w equals 4. Right? Well, this is a 1 in front of here. So we're doing 1 divided by 2, right? That's going to equal just 1/2, right? 1/2, right? And then we're going to take our 1/2 and we're going to square it. Right? Well, 1 times 1 is 1, and 2 times 2 is 4, right? So that's what we're adding to both sides. So this is w squared plus w plus 1/4. Okay, and that equals tell you what, we're going to need both these to have the same one, right? So we're going to be adding a 4th to this. So we need this to have a common denominator. So I want to go ahead and set this up, that way we can do this in the next step. So this needs to be over 4. Well, to get 1 to be 4, we have to multiply it times 4. So 4 times 4 is 16. Okay? Set up for that. All right. So this is going to simplify into w plus 1/2. Right? We take it from right here. And this is squared. Equals, and 16 plus 1 is 17 over 4. Right? So then we're going to take the square root of both those. Okay? Take the square root of this. W plus 1/2 squared. And we're going to get plus or minus square root of 17 over 4. Well, we can get the square root of 4, right? So we can make this come out. W plus 1/2 equals, and we can have plus or minus square root of 17, and then we can take the square root of 4, which is 2, right? What I was about to say. And now we're going to need to subtract our half, right? Subtract our half. Subtract our half. Okay. And so we get W equals negative half plus or minus 17 over 2. Oh no, I'm sorry, it didn't. One way we can write this, I guess, to simplify this, we could actually just combine these together. Okay, so you could write this as negative 1 plus or minus square root of 17 over 2. See, since those are both the same, you can just combine it in that sense. Okay. And then your solution set would just be both those. So it would be negative 1 plus square root of 17 over 2 and negative 1 minus square root of 17 over 2. Sure? All right. 55. All right, we got m squared plus 5m minus 2. Now it's saying use the quadratic formula. Remember, the quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So what we're going to do is get a negative. And remember, this is our b. The number in front of here is our a. Remember, our understood number is a 1 if there's nothing there. And then our c is going to be this negative 2. So we get a negative 5 plus or minus. And then just naturally negative, and that's a 5 that gets replaced there. And then we're going to do the square root of 5. I mean, sorry, not the square. This not the square root, but the square of 5. Minus 4 times 1 times negative 2. Okay? And this is all over 2 times 1. Right? So we get negative 5 plus or minus 5 squared is 25. This is minus, actually this is going to be a plus, because this is negative 4 times 1, which is negative 4, times a negative 2, which is a positive 8. And this is all over 2. Okay. Next thing we get negative 5 plus or minus and the square root of 33 over 2. Right? I couldn't simplify that any further. In fact, we can't. So we are left with this being our answer. So negative 5 plus the square root of 33 over 2 and negative 5 minus square root of 33 over 2. Okay. One last answer. It'd be really cool if I had sleeve tattoos, huh? Make me look meaner while I'm doing these videos. Alright, we got 7y minus 6 plus 24y squared equals 0, right? We're not used to seeing it this way, right? We're used to seeing it as 24y squared plus 7y minus 6, right? So that would make it better for you instead of going, oh god, that's our A, there's our B, and there's our C. So we can just say, okay, this is our A, this is our B, this is our C. Okay, so we're going to plug this in from our formula. Remember, it's negative B plus or minus B squared minus 4AC all over 2A. Okay, so we're going to get negative 7, right, plus or minus 7 squared minus 4 times 24 times negative 6 all over 2 times 24. All right, so we get negative 7 plus or minus, and you get 49. And we got a negative times a negative, which is going to make a positive, so I'm not even going to, well, what's that, but 4 times 24 times 6 equals 576. 70 plus 576. And this is all over 2 times 24 is 48. We get negative 7 plus or minus square root of, and I'm going to do this, plus our 49. That gives me 625 over 48. And now I'm going to try to take the square root of that. So let's see if we can get that. That is going to be 25. So now we're down to negative 7 plus or minus 25 over 48. Okay. And so this can split into it. So this is going to be negative 7 plus 25 over 48, and we got negative 7 minus 25 over 48. Okay. Well, negative 7 plus 25 is going to be 18 over 48, and we can reduce that fraction, divide them both by 6. So this is going to be 3 over 8, right? Then we got negative 7 and negative 25. This is going to be negative, negative 32 over 48, right? And we can reduce these fractions. This is going to be, divide them both by 8. So that's going to be a negative, actually we can divide them by 16, right? So this is a negative, negative 2 times 16 goes into there 3 times. So this is negative 2 over 3. And that's going to be our final answer. Another cool thing to show you, too, is if you have one of these calculators, you can actually look it up online. You can email me. I'll send you the link if you want it. But you can program your calculator to just do the quadratic equation for you. That way you don't have to do all this garbage. And so what this does, once you program this thing in, is you can just enter these things. So you can enter 24 here, you can enter 7 here, and then negative 6 here. And it's going to just calculate it for you. Okay? And you can see that our answers are that. You kind of got to know how to reconvert that back into it. But, you know, 0.6 and negative 0.6 repeated is in correspondence to this, right? And if also we did 3 divided by 8, it equals that 375. So that's where those two came from. So if you want instructions If you want to just go look it up and try to find it yourself, you're more than welcome to. But just look up, quadratic equation in the TI-84, and there's videos and.
All right, this equation is x squared plus x plus 2 equals 0. It tells us to use the quadratic formula. Now remember, the quadratic formula follows this. It is negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So remember, all we do is just plug these things in. Remember, this is the number in front of our x squared. That's going to be our a. The number in front of this one is going to be our b. And this number right here is going to be our c. Now, the understood numbers in front are ones on this one, right? So we're going to have a negative 1 plus or minus, and this b is going to be squared, so it's just 1 squared minus 4 times 1 times 2. And this is all over 2 times 1. Okay? So we're going to simplify this, and here 1 squared is 1, and then we got minus 4 times 1 times 2. 4 times 1 times 2 is 8. So this is just negative 1 plus or minus, and we did 1 minus 8, which is a negative 7, plus or minus there, and then 2 times 1 is 2. Now we can simplify this a little bit. We can say that this negative square root actually makes an I come out, so we could look this like it's negative 1 plus or minus I square root of 7 over 2. And if they want you to express this as a this split apart, you could just say that this is a negative 1 over 2. Let's do minus first. Square root of 7. Oh, square root of 7. Root of 2 there instead. Over 2, and then we can throw our I on the outside here. And so our other answer is negative 1 over 2 plus the square root of 7 over 2. So it's just both versions of this thing. Okay. All right, we got 7x squared minus 3x plus 5. We're going to call this our A, call this our B, call this our C. Okay, so we're going to say it's a negative 3, which is what that negative b is, so it's going to be 3 plus or minus, and now we got a b squared coming from our formula we had on the last one. This is a negative 3 squared minus 4 times a, which is 7, and then c, which is 5. Okay, and this is all over 2 times a, which is 2 times 7. Can't do much with that. This negative 3 squared is going to become a 9, and then 7 times 5 is 35 times 4, that's going to be 140. Okay, and this is over 2 times 7, which is 14. Okay, we can simplify this. This is going to be 3 plus or minus, and now this is the square root of negative 131, and this is all over 14. Okay, the only thing more we can do with this is just take out that negative out of the square root, which is an imaginary number, and then we got square root of 131, and this is over 14. They may want it in standard form, so you can split this out and write it as 3 over 14. Let's make a solution set. Minus square root of of 131 over 14 I. And then our other one is 3 over 14, and we get the plus. And it's the same thing, square root of 131 over 14 I. And that's our other answer.